Before exploring Jeff Bezos' space-based AI vision, it's essential to understand the context of modern AI computing. Artificial intelligence, especially large-scale models such as reasoning AI, generative systems, and multimodal models, has evolved into an industrial-scale technology. Unlike early AI, which ran on academic servers and modest computing clusters, today's models are truly global infrastructure, requiring enormous computational and energy resources to train and maintain. For instance, the largest AI models today require electricity comparable to powering 120 U.S. homes for an entire year just for a single training run. This does not include the energy for inference, the day-to-day operation that powers AI applications for businesses, research, and consumers. The environmental footprint of AI is rising rapidly, and even data centers using green energy are constrained by land, cooling requirements, and energy transport limits. Bezos' vision is ambitious because it addresses these core constraints. Space offers near-unlimited solar power, minimal land requirements, and efficient cooling possibilities. Moving AI computing infrastructure into orbit could redefine the economics of AI, reduce energy bottlenecks, and allow models to scale in ways impossible on Earth. In essence, this is not just a technological idea. It's an economic and strategic pivot that leverages outer space as an industrial resource. Jeff Bezos recently unveiled a bold vision: the construction of AI data centers in outer space. These are not mere experiments. The idea is to build full-scale, operational facilities capable of powering large AI models entirely off-planet. The concept merges two of Bezos' passions: AI and space exploration, the latter through his company Blue Origin. By placing computing infrastructure in orbit, Bezos aims to create data centers that are both highly scalable and energy independent, powered exclusively by the sun. The potential of this approach is enormous. Space-based AI data centers could theoretically operate continuously without reliance on terrestrial electricity grids. They could tap into gigawatts of solar energy without land constraints, minimizing conflicts over real estate or terrestrial resources. Furthermore, orbiting centers could leverage vacuum cooling, significantly reducing the energy needed to manage heat generated by high-performance AI hardware.
From a strategic perspective, Bezos is positioning himself at the intersection of two industries poised for exponential growth: AI, which drives enterprise value, automation, and digital transformation, and space infrastructure, which promises to redefine logistics, communications, and resource utilization. For businesses, governments, and technologists, this signals the emergence of a new paradigm where space is no longer just exploration, but a fundamental enabler of computational innovation. The energy demands of AI are a major driver for Bezos' proposal. Today's AI training models, particularly reasoning and generative models, consume massive amounts of electricity, often creating environmental and operational challenges. On Earth, data centers compete for land, energy, and cooling capacity, and even renewable solutions are limited by physical constraints. Space offers multiple advantages: unlimited solar energy. Orbiting facilities can continuously capture solar power without interruptions from night cycles, weather, or atmospheric interference. This could supply terawatt-scale electricity, enough to sustain multiple large-scale AI clusters simultaneously. No land constraints. Terrestrial data centers require extensive real estate, often leading to environmental concerns or conflicts over land use. Space removes this limitation entirely, enabling virtually limitless expansion. Improved cooling and efficiency. AI hardware generates enormous heat. Cooling on Earth accounts for a significant portion of total energy use. In space, vacuum conditions and advanced radiative cooling systems could dramatically reduce these costs, improving overall energy efficiency. By placing AI infrastructure in orbit, Bezos aims to create a self-sustaining ecosystem for AI research and development that decouples energy and space limitations from the pace of AI innovation. This approach could accelerate both technological advancement and adoption of large-scale AI systems across multiple sectors. Despite the promise of orbit-based AI, Bezos recognizes the current AI industry is in a speculative bubble. Investment is flooding in from venture capital, tech giants, and national governments, but not all companies have viable technology or sustainable business models. The result: inflated valuations, hype-driven startups, and competition that often prioritizes speed over substance. Bezos' critique is twofold. Investor myopia. Many investors are chasing the AI gold rush, unable to separate short-term hype from long-term viability. Companies that appear successful on benchmarks may lack practical applications or scalability. True innovation versus noise. Bezos argues that only firms capable of producing measurable productivity gains, real-world AI adoption, and industrial integration will survive long-term. Orbit-based AI centers are his bet on those winners, providing a strategic infrastructure advantage that goes beyond hype. He also frames space-based AI as a way to future-proof technology. Even if AI companies face market corrections or public skepticism, those with robust, energy-independent infrastructure will maintain competitive advantages, enabling them to scale and deploy AI models in ways that competitors cannot replicate. Bezos' vision, however, faces public skepticism and technical concerns. According to Pew Research, the U.S. population is deeply divided on AI. 34% are worried about AI's rise, fearing job loss, surveillance, and misuse. 42% are both excited and anxious, reflecting uncertainty about whether AI benefits will outweigh risks. Only 16% are predominantly excited, indicating limited public enthusiasm for speculative projects like orbit-based AI. Globally, concern is even higher in regions with less technological exposure. Critics question the feasibility of orbit-based data centers, the potential costs, and the risks of technical failures in space. Others worry about centralized AI power in private hands, potentially consolidating influence in the hands of a few corporations. This skepticism is not without merit. Space-based AI requires solving enormous engineering, logistics, and safety challenges, including launch costs, radiation protection, and maintenance. Bezos will need to demonstrate both technical feasibility and public benefit to gain widespread support. Bezos predicts that within 10 to 20 years, humanity could begin building gigawatt-scale AI clusters in orbit, effectively creating a new paradigm for computational infrastructure. He argues that space-based AI will eventually become cheaper, faster, and more reliable than terrestrial alternatives due to unlimited solar energy, modular deployment, and efficient cooling. The potential implications are profound. Interplanetary AI ecosystem. Large-scale orbit-based AI could support planetary-level projects in climate modeling, logistics, autonomous transportation, and space exploration. Economic advantage. Companies or nations controlling orbital AI infrastructure may gain strategic and financial advantages, from faster research cycles to enhanced AI-driven decision-making. Civilizational shift. Bezos frames this as a leap not just for technology, but for humanity. By offloading industrial-scale AI to orbit, we might reshape the boundaries of human labor, energy consumption, and scientific progress. In short, Bezos' vision redefines AI's future as interstellar rather than merely digital, positioning space as a core enabler of the next industrial revolution. While challenges remain, the combination of vision, engineering ambition, and strategic foresight makes orbit-based AI one of the most fascinating and potentially transformative projects of the 21st century.